Life. The most complex phenomenon we know. It can grow, adapt, and evolve. But the most important question is this: did life appear only on Earth? Or is it a natural process of the universe itself? To find the answer, we must return to the very beginning. To a time when there were no planets, no stars, not even atoms as we know them today. About 13.8 billion years ago, the universe was born in an event we call the Big Bang. Space and time appeared simultaneously. Energy began to cool, and from it, the first particles emerged. At first, the simplest ones: protons, neutrons, electrons. Over time, they combined into atoms of hydrogen and helium. These became the first building blocks of everything that exists. But life cannot arise from hydrogen and helium alone. It requires more complex chemistry. And this is where stars enter the story. The first stars were enormous. They burned brightly and lived briefly. Inside their cores, nuclear fusion took place. Hydrogen turned into helium, helium into carbon, then into oxygen, nitrogen, and iron. When these stars exploded, they scattered these elements across space. Quite literally, the atoms that make up your body were once born inside stars. Without stars, the chemistry of life would not exist. But elements alone are not life. They must meet under the right conditions. In interstellar space, there are vast clouds of gas and dust. For a long time, scientists believed these regions were too cold and empty for complex chemistry, but telescopes revealed something unexpected. Within these clouds, organic molecules form: amino acids, alcohols, even sugars. This is not life, but it is its foundation. These molecules can travel for millions of years, enter new star systems, and settle on young planets. In this way, the universe itself may distribute the ingredients of life. There is an idea that radically changes how we view the origin of life. It is called panspermia. According to this hypothesis, life, or its precursors, can be carried through space. Meteorites, comets, cosmic dust. On Earth, scientists have found meteorites containing amino acids. Some of these compounds could never have formed under Earth's conditions. This suggests that the basic chemistry of life may be far older than our planet itself. But even if the ingredients came from space, where did life truly take its first step? About 4.5 billion years ago, Earth looked nothing like it does today. No modern oceans, no oxygen-rich atmosphere, constant volcanic activity, relentless asteroid impacts. And yet, this is where life appeared. At least, as far as we know, the first living organisms were incredibly simple, single-celled, without nuclei, without complex structures. But they possessed one crucial ability: they could replicate. And that was enough for evolution to begin. This is the central question. Was the origin of life a unique cosmic accident? Or is it a natural outcome of chemistry that occurs throughout the universe? Modern science increasingly favors the second answer. If there is water, energy, organic molecules, and enough time, life can emerge. And such places in the universe number in the billions. Astronomers have already discovered thousands of exoplanets. Some are rocky, some have oceans, some lie within the habitable zone. But life does not need to resemble life on Earth. It may exist beneath ice, like on Jupiter's moon Europa, or in vast subsurface oceans, like those on Enceladus. Perhaps life is everywhere, just incredibly quiet. Perhaps life is not an exception. Perhaps it is a phase in the evolution of matter. When conditions are right, chemistry becomes biology, and biology becomes consciousness. And if that is true, then we are not an accident. We are part of a process that began long before Earth and will continue for billions of years to come. We look into the cosmos and ask, is there life out there? But perhaps the better question is different. Not, is there life in the universe? But, how much of it is there? Because if life can arise from stardust, then the universe is not empty. It is alive. And perhaps, it is only beginning to reveal its secrets. The universe is vast and ancient. Stars are born, live, and die. Galaxies collide. Planets form and evolve. And somewhere in this endless cosmic dance, life continues to emerge. After the first cells appeared on Earth, life began an extraordinary journey. From single cells to complex multicellular organisms. From the oceans to the land, evolution sculpted the diversity we see today. But Earth is not unique in its potential. The same processes, chemistry, energy, and time, exist throughout the cosmos. In the depths of space, around distant stars, planets orbit in the habitable zone. Some are rocky. Some may have oceans. Some may have atmospheres rich in nitrogen and oxygen. On these worlds, chemistry continues to experiment. Organic molecules collide, bond, and form complex structures. Energy from stars powers chemical reactions. Volcanic activity, lightning, and radiation create conditions where life could ignite. The building blocks of life. Amino acids, nucleotides, sugars, have been detected in interstellar clouds. In some comets, these molecules have traveled billions of kilometers. Every time a comet or meteorite strikes a young planet, it delivers these prebiotic ingredients, seeding the potential for life to begin. Life is resilient. It emerges where the conditions allow. Extreme temperatures, high radiation, or lack of oxygen do not necessarily prevent its appearance. Microbial life on Earth has been found thriving in boiling hydrothermal vents, frozen tundras, and acidic lakes. This adaptability suggests that life could exist in forms very different from what we recognize. Life could exist under thick ice layers, on moons like Europa or Enceladus, hidden from view yet active. It could survive beneath dense atmospheres, or in oceans of liquid methane. The process that creates life may be universal. From the chaos of molecules comes order. From random chemical reactions, a self-replicating system emerges. Once replication begins, evolution follows, shaping organisms over millions or billions of years. The panspermia hypothesis proposes that life may not be confined to a single planet. Comets, asteroids, and interstellar dust could transport microscopic life between worlds. Perhaps the seeds of life on Earth arrive from beyond our solar system. But even if life is widespread, it may be rare in complex forms. Simple life, microbes, and single-celled organisms may exist abundantly. Complex multicellular life, capable of intelligence, could be extremely rare. As humans explore space, we are just beginning to uncover this cosmic story. Telescopes detect exoplanets. Robotic probes measure atmospheres. We search for biosignatures, chemical evidence of life. Mars may have once had oceans. Venus may hide ancient microbial life in its clouds. Titan and Europa may conceal active ecosystems beneath icy shells. The discovery of extraterrestrial life, even microbial, would rewrite our understanding of biology. It would confirm that life is not a random accident. It would show that the universe has the capacity to create living systems wherever conditions allow. Life is not just a property of Earth. It is a process inherent to matter itself. Stars produce the elements. Cosmic clouds create molecules. Planets provide environments. And chemistry does the rest. This process is ongoing. Every moment, molecules form, collide, and react. Throughout the cosmos, new stars and planets continue to emerge. Some may already host life. Humanity's place in this story is unique. We are observers, thinkers, and explorers. Through science, we uncover the universal patterns that make life possible. Through technology, we reach further into the cosmos. As we study exoplanets, we consider possibilities. Could life exist in different chemistries? Could it breathe ammonia, swim in liquid methane, or survive under high radiation? Could it perceive reality in ways we cannot imagine? The origin of life is not a single event. It is a continuum. From atoms to molecules. From molecules to self-replicating systems. From simple organisms to complex ecosystems. Life is a process that unfolds over cosmic time. The question is no longer, is there life beyond Earth? But, how many forms of life exist in the universe? The cosmos may be teeming with life, or it may be sparsely populated. Either way, each discovery brings us closer to understanding the universal principles of biology. Life in space is the ultimate expression of resilience. It adapts, survives, evolves. It responds to its environment, finds niches, and thrives. As humans, we are part of this continuum. Our cells contain elements forged in ancient stars. Our DNA echoes the processes that began billions of years ago. We are a product of the cosmos, and a participant in its ongoing story. In the next decades, our exploration may expand. Robotic missions to icy moons, advanced telescopes scanning distant worlds, and eventually human travel beyond Earth. With each step, we may uncover signs of life, from the tiniest microbes to complex organisms. Every discovery will reshape our understanding of ourselves, our origins, and our place in the universe. Life is not confined to Earth. It is a cosmic phenomenon, a testament to the creativity of chemistry and physics. And it reminds us that the universe is alive in ways we are only beginning to comprehend. The story of life in space is still unfolding. Every star that forms, every planet that coalesces, every molecule that bonds brings us closer to understanding how life emerges, evolves, and thrives. And in this vast, mysterious universe, we are not alone. We are part of a larger, living cosmos.